Oof, okay. Yes, the time is good. It looks like we just got the recording bot to start. So yeah, whenever you're ready, you can go ahead and start.
Sounds good. Hi, everyone. Welcome to the AI Agents Workshop. In light of the theme of this hackathon, I will be presenting on AI agents as learning and teaching tools, with a heavy focus on the fundamentals of AI agents. So, a little about me, I'm a senior at Boston University. I major in math, computer science, and economics. I've also interned at Google and worked on Google Ads, Android, and YouTube, which I will be returning to full time after graduation. My work spanned across infrastructure, APIs, and distributed data pipelines. My main interests are distributed systems, computational complexity, and cryptography, especially post quantum cryptography concerning hard lattice problems. If any of these interest you or you just want to have a little chat, feel free to send me a DM on LinkedIn or Discord. Before we get started, here's an overview of the topics I will and will not be discussing in this presentation, because I think this is an important distinction to make. This workshop will focus on building on top of existing LLMs to make AI work for you. This includes ideas of human AI interaction and how to build AI agents, aka how can we exploit the power of AI to build tools that are more intuitive across different use cases. I will also talk about some of the past and current research with LLM prompting techniques, since that lies at the core of building a good AI agent. However, this workshop will not focus on classical machine learning, things like Markov chains and Bayesian methods, and will not focus on deep learning, including transformers and model fine tuning. And I also want to explain why the focus on human AI interaction, especially in today's tech sphere, is relevant and important. So we've all seen how technology has advanced at lightning speeds for the past few decades, maybe 20, 30 years ago. Most people could not have envisioned what technology looks like today. So it's very likely that technology 30 years later will look very different than it does now. However, human evolution is very, very slow, and we've remained relatively unchanged for the past tens of thousands of years. Thus, we need the field of human computer interaction to make up for the difference between technological ability and human ability. Technology is only as helpful as the extent that we are able to use it. If a new technology has too much opportunity cost to use, or the barrier of entry is too high, then it's less likely that people will actively change to using a new technology. In the past 4 years, with how rapidly AI has advanced, human AI interaction then becomes important in terms of how do we best incorporate AI into different problems that we face, such that AI can enhance our productivity and serve as a tool that people can easily adopt. The idea of AI itself isn't actually too new. In fact, the conceptual roots of today's AI and large language models lie directly with Alan Turing. His theoretical Turing machine is the blueprint for computational architecture of all modern AI. More critically, the Turing test, or the imitation game, which establishes the indistinguishable human like conversation as the metric for intelligence, precisely defines the primary function of a modern LLM. LLMs are, therefore, the most successful practical realization of Turing's original 1950 vision. Machines whose utility and apparent intelligence are measured entirely by their ability to successfully interact with and assist humans via text. And our ideas of artificial general intelligence is most like the best verifier we can feed into the Turing test, which he describes as the quote unquote adult machine. The fundamental ideas of AI take root from the very beginnings of theoretical computer science. While the Turing machine is still quite far from AGI, aka artificial general intelligence, aka the adult machine, it was definitely a revolutionary child machine, which proved the idea that complex, seemingly intelligent behavior can emerge from a deterministic and algorithmic process. You can see that on this graph here as the Turing letter, which refers to the paper mentioned on the previous slide with the quote. This started the surge of optimism for AI, where the field of artificial intelligence was officially established in academic research at the Dartmouth Workshop in 1956. However, people quickly began to realize the importance of how we use AI and machinery, which led to Sutherland's development of the Sketchpad in 1963, which was the first graphical user interface. This marked the first breakthrough of human-computer interaction. Then the IPTO formed in 1970 and provided a source of funding for AI research, which led us back into the AI development era. Unfortunately, a report in 1973 that discredited AI research in UK led to several funding cuts for AI. During this time, there was formal establishment of human-computer interaction labs as computing became more mainstream and usability issues became critical. Then in 1981, a massive Japanese initiative to create a fifth generation of supercomputers using parallel processing and logic programming launched us back into the AI era, though unfortunately it failed to deliver on its ambitious goals. Then in the early 1990s, the field of human-computer interaction gained widespread academic legitimacy and integration into the computer science curriculum. The internet bubble in the late 90s and the early 2000s restored optimism in AI-related research with the surge in internet. Then human-computer interaction had to catch up to support the rising popularity of personal computers, which then became a household essential at the turn of the century. Now, in 2025, we are again at a peak of AI optimism with the development of large language models, which has quickly developed to improve reasoning and support many different forms of media input and output. But as we see from history, the rapid development of computing and AI must be paired with human-computer interaction so that we can coexist with the new technology. One of the most direct ways that people can take advantage of AI is through AI agents. So first off, what exactly is an AI agent? An AI agent is an autonomous software system that perceives its environment, reasons, creates a multi-step plan, and takes actions to achieve a specific, often complex goal on behalf of a user. AI agents are everywhere nowadays, and here are some Gemini agents that I ran into while I was making this presentation, such as asking Gemini for help in Google Drive, or asking Gemini to create slides, or asking it to generate an image to insert into my slides. Even when I open files in Google Drive, Gemini will automatically provide a summary of the file for me. That's an AI agent. Although AI tools are probably the most common forms of AI agents that we encounter, it's not the only use for AI agents. For example, right now I'm working on a research project that evaluates how LLMs perform in social deduction situations. So I created a custom sandbox where multiple AI agents play among us with each other. And you can see that with enough prompting and context, you can ask the LLMs to act as a character and think strategically from that character's perspective, such as yellow up here, where the LLM takes on the role of the logical deductor as a crewmate and evaluates the map to determine the optimal way to do tasks. And then down here, where the LLM takes on the role of the aggressive accuser as an imposter and thinks about the way they can blend into crewmates while setting up the best opportunities for a kill. This really just shows how versatile AI agents can be, and you can be very creative with how you approach it. With that said, how do you go about building an AI agent? First off, you definitely need an LLM API. Here are some cheap options to get started. We have the Azure OpenAI, which gives you access to most OpenAI models, and I believe it comes with a $100 trial credit. We have Google AI Studio, which gives you access to most Gemini models and comes with a $300 trial credit. Then lastly, we have Hugging Face Playground. Hugging Face provides a lot of open source models and offers an API to access these models, which I believe has a free tier. Then you will need tools. After LLM decides on an action, you have to be responsible to make sure the action gets implemented. Depending on what you're building, you might need external functions or other APIs to do specific tasks. For example, booking a meeting or updating a calendar, things like that. Your interactions with the LLM through API are often stateless by default. So if you want to iteratively prompt the LLM with past interactions and context in mind, you will have to implement your own state, just some kind of database or memory to keep track of your progress. Lastly, you will need an orchestrator to manage the entire cycle of operation, seeing it through from gathering input to prompting LLMs to executing tools to updating state. This establishes agentic autonomy. Now that looks like a lot to code up, but you can also ask AI to write a lot of the code for you. Vibe coding usually works the best when you have a clear plan for the workflow that you want to establish. For example, let's say your goal was to build an AI agent that can find related research papers. Given a input paper abstract with a web interface for uploading the input paper abstract and returning relevant paper information, your workflow could look something like this. You start off by asking the LLM to read the abstract by sending it along with your prompt. Then the LLM generates queries that could most likely find the best related papers, which is then sent to a tool to get the top 50 related papers. When you get the results back from the tool, you can ask the LLM to add a little note of how similar the papers are and why they're similar. Then you can output the result. When you establish a clear workflow diagram like this, it's usually pretty fast to get a working model for your AI agent. Then debugging will be the hard part. As we can see from the workflow, the role of LLM is central since it acts as the brain in determining actions. This means that prompt engineering is also crucial. It can make or break your AI agent. A good prompt should minimize errors and unexpected action items. So first off, we want to enforce a structured reasoning. We want to have the agent follow the sequence of thought, action, and observation, such that it always stops to think before recommending an action. And depending on your use case, maybe it should stop and evaluate the results of the action before proceeding. You also want to set the persona and goal, which lets the agent get into character, gives the LLM a role, some constraints, and a success criteria. You should also provide clear documentation of the tools that you are using to execute your actions so that the LLM knows how to respond in order to correctly help you execute the tool. You should provide clear descriptions of each tool and API, especially if you're using an external API. Make sure to provide the exact function signature and input-output structure. This will make it much easier to parse the LLM responses to extract the right actions to execute. Lastly, it's been proven that LLMs perform better with a few-shot examples, where you can feed the LLM examples of what you would expect a successful run to look like. This will give the LLM an idea of how to handle success, failure, and tool selection. If you need the LLM to perform intensive reasoning tasks, it may also be helpful to use chain of thought prompting, where you ask the LLM to think logically step by step in order to arrive at a conclusion. It's also been proven through research that LLMs are more accurate when you prompt with chain of thought prompting. Here's an example of a good prompt. You start off by giving a role to the AI agent in the system prompt. In this example, we are asking for a market researcher. Then we give it a goal. We want it to generate a 5-point summary of a company's stock. The LLM should use all information made available to it and never fabricate data. Then it must output its thinking process in the exact sequence of thought, action, output until reaching the final summary. Then we can define the toolkit in a JSON format so that we are giving it a search engine tool so that it can search the web, and a stock price tool so that it can retrieve current stock prices. Lastly, we give it an example. For example, what is the latest on Google stock? Then we give it thoughts and actions that we expect. It should start by checking the current stock price, and it does by calling the stock price tool, and it notes down the final result. Then it should use the search tool to find recent news and observe the main points. After using all the tools, it can now form the summary, including current price and important news and updates that could affect future stock prices. Then it ends with an advice, which in this case is cautiously positive. Then you can add the user request onto this prompt, something like, what's the latest on Microsoft stock? And you would expect a similar output from AI following the format of the example that you gave to it. This is pretty much all you need to know to start building your own AI agent. So let's see a few examples of AI agents others have built to facilitate learning and teaching. One really cool example I came across was the project Augmented Physics. The overall idea of this paper is that they utilize multimodal LLMs to generate interactive programs and charts from static images in physics textbooks. The paper noticed several limitations with the current way that students are learning physics, specifically regarding the limitations in augmented interactive explanations. Often, learning physics requires developing a certain intuitive understanding of how physical objects interact, which is difficult to communicate through a static textbook. They point out 4 main points. Number 1, static diagrams do not depict motion or changes over time. So if you're trying to learn the topic regarding a range of motion of an object or time-dependent systems, which is very common in physics, you would have to be able to visualize movement off a static diagram, which could be hard to do. Number 2, many students are often directed to YouTube videos to see the moving visualizations, but these are limited in the sense that students cannot directly interact with or experiment with things in a YouTube video. Number 3, many teachers often resort to using external simulation tools, which do provide interactive moving visualizations, but it's not guaranteed that these simulation tools will be 100% aligned with the classroom curriculum. In the case when it doesn't, students often have to manually contextualize and bridge the gap between external simulation and what they're currently using. Number 4, referring to the external sources can be distracting. You have to filter out irrelevant information to find the key parts that are actually aligned with your curriculum and helps you understand. It could be distracting for students to go on YouTube and watch videos because they could be extracted by other videos in the recommendations, for example. That's where their idea of a tool that brings physics diagrams to life came from. In order to requirement gather for this tool, they consulted physics TAs and instructors from their local university, gathered their feedback from a first-year undergraduate physics textbook, and identified 4 categories of augmentation techniques that this tool or their AI agent should be able to handle. The diagrams below show examples of what the physics instructors has labeled the diagrams from a teacher's point of view to best help students understand how diagrams should be viewed. Let's see an example of how their tool animates each of these categories. So first up, augmented experiments. In this circuit simulation, students can alter voltage and resistance and observe how that affects the amperage in the circuit. Next, animated diagrams. The left one is a light refraction diagram. The student can segment a fraction path, and the tool can animate the photon through the path. The right one is an animation of an object orbiting the sun. We also have bidirectional binding. This shows how students can change the compression amount of the spring and the spring constant in a kinematics diagram, which then the simulation can run based on this updated value. Lastly, parameter visualization. From this visualization of a pendulum, students select a specific parameter, which in this case is the angle of the pendulum. They run the simulation and a graph is produced charting the angle over time. So how did they implement this? This is the tech stack of their implementation, which involved many different tools, LLMs, and libraries. Notably, they used the Google Cloud Vision API for text recognition and extraction of numerical values, which is then sent to ChatGPT-4 to recommend the simulation type. So this is the data flow of the end-to-end execution. Number 1, user input and transmission. User selects and submits an image segment from the front end. Number 2, computer vision and pre-processing. Backend processes the image for segmentation, feature detection, and coordinate calculation. Number 3, text and numerical extraction. The system extracts text and numerical values from the processed image segments. Number 4, simulation setup and parameter setting. Extracted data is sent to the LLM to interpret the diagram's context and goal, and then set the simulation parameters. Number 5, data aggregation and final transmission. All extracted and computed data, along with LLM recommendations, are compiled and sent to the front end. And lastly, front-end execution. The front end receives the structured data and initiates the appropriate simulations. I think this really shows how important it is to have a clear diagram of where you are going to manage all the different steps of your AI agent. Some automation logic can get complex and messy very quickly, so make sure you know what each step depends on and what each step is going to output. Next, I do want to introduce a lot of coding assistants, not only because they're good examples of AI agents, but I also think they can be really helpful when you're learning to code something from scratch. For example, your own AI agent. Oftentimes, when you're building a large code base and you send snippets of your code to GPT for help, this particular snippet that you send is based on some underlying assumption of where you think the problem has occurred. But with something like Cursor, it has context of the entire code base, which can help you debug faster and learn better coding practices. Cursor is an AI native code editor built on top of VS Code, such that it allows developers to interact with their entire code base using natural language. It supports multi-file refactoring, debugging, and code generation with awareness of the whole project structure. Cursor is also most identical to the AI features available in Google's internal IDE that most Google developers use, so learning to integrate AI into your programming workflow is pretty important to learn. Another coding assistant option is Claude Code, which is Anthropic's agentic coding tool that often operates in a terminal. Unlike inline suggestion tools, Claude Code is designed to be more of an autonomous teammate. It can map and explain an entire code base, break down complex problems step by step, and directly edit files, run commands, and even manage Git operations through natural language prompts. This gives you more of a pure vibe code experience if that's what you're looking for. Another option that's primarily conversational is OpenAI Codex, which is the large language model developed by OpenAI that was specifically fine-tuned on natural language and billions of lines of public source code. It serves as the underlying AI foundation or engine for several coding tools, most notably the original GitHub Copilot. Its core function is to translate natural language into code and provide context-aware code suggestions and completions, essentially mapping simple problems to existing code patterns to speed up routine programming tasks. And lastly, GitHub Copilot. It's an AI programming assistant developed by GitHub and OpenAI. It primarily serves as a plugin or extension for popular IDEs such as VS Code or JetBrains Suite. It provides real-time inline code suggestions and completions as the developer types. It can suggest a single line, a function, or a whole block of boilerplate code based on the current file's context and comments. It's often seen as an intelligent pair programmer that helps with writing features, generating tests, and automating repetitive coding. With that said, here are some quick and easy hackathon project ideas if you do want to create an AI agent for learning/teaching. Number 1, a cheat sheet agent. This is perfect for exams where they allow you to bring a single sheet of notes so that an AI agent can take all of your class notes and help you identify the most important details and create the cheat sheet. Number 2, mini tutor agent. This helps tutor students according to their specific level. The agent can start with a small quiz to understand what level the student is at with a particular subject, and then adapt difficulty in real time during tutoring. Number 3, flashcard agent. This is like Quizlet Premium, but free. You can create an agent that generates flashcards and quizzes from notes, and then based on what you get wrong, it would selectively repeat certain topics to help you learn the material better. Number 4, rubber ducky agent. This can be very helpful in helping students understand bugs in their code, going line by line to check for gaps in comprehension, and then gives them some potential debug options and tips when they get stuck. And that's it. Happy coding and happy hacking. I will open the floor to any questions, and I've also dropped my LinkedIn QR code here if anyone wants to connect or reach out.
So there's one question that's been in the chat for a little bit since you started.
Oh, yeah.
From
sorry.
Michelle. No, you're good. You're good. I figured you were waiting until the end for Q&A. So she asked, are we currently at a full peak of AI optimism? While there's a lot of funding, there's also a lot of hesitancy to adopt for various valid reasons.
Yeah, I think more than ever, compared to the other peaks of AI optimism we've had, AI ethics have become a bigger and bigger question, especially with LLMs and what they're training on. It's not the same as, we have an quote unquote AI with like a computer, with a personal computer and stuff. LLMs are very different because you don't know what type of information they're training on. And I guess various news have come out in recent times about like, maybe they're using personal data to train their AI agents. And I think we are at a peak of AI optimism in the sense that we are pulling a lot of funding into AI at unseen amounts previously. But I also feel like, maybe this is just me, but I also feel like it's starting to slope off a little bit, especially after I saw news of like, OpenAI is asking for like a loan from the government and that type of stuff. I think when companies typically start doing that, that you're running into some like issues with, where you think your business is headed.
Oh yeah. Michelle said it's the tech bubble. I've definitely heard people use that term to talk about AI, and then also like stock in NVIDIA for sure.
Yeah, and I think like, at what point is NVIDIA stock overvalued, right? Because I think people said that like a year ago, and then like 11 months ago, and 10 months ago, and then 9 months ago. Everyone's like, yeah, NVIDIA is definitely overvalued now, and then it just keeps going, right? And it's like as the bubble gets bigger, it's like more and more people are more scared at the point where it pops.
Yeah, for sure. Okay, I see Amara typing in the chat. Oh, here's one. Since I don't really do a whole lot of work with AI and LLMs, how is training AI agents different than just training LLMs? Like, I don't know if there is a difference.
Yeah, good question. So that was actually part of the reason why I wanted to make a distinction at the beginning of what this workshop is and is not about. So using like training AI agents, you're not changing the fundamental LLMs. When they're training LLMs, it's using a lot of, classical machine learning techniques and deep learning techniques where you're going in there, you're spending hours training the model, fine-tuning the model, you're feeding it different inputs so that, the model fundamentally changes. But with an AI agent, you're not fundamentally changing anything about the LLM. You're just taking the existing thing that people put out publicly. For example, OpenAI puts out, a ChatGPT version publicly, and then you're using ChatGPT, but you're placing a custom prompt on top of it so that it can do more stuff than just a traditional chatbot. Does that make sense? I'm not sure if I explained it clearly.
Yeah, that definitely helps a lot.
And I think like building AI agents is a lot more accessible than, like training your own models, because I think that can often be the barrier of entry of training models is definitely a lot higher than building your own AI agents, that I would say.
Okay. Yeah, that definitely makes sense. Yeah, and then Amara brought up the competing demand for data centers versus what we already have, and the ethical issues with them being developed in minority communities. Yeah, no, the development of data centers is definitely kind of scary also, considering that they use up natural resources and land and all of those things.
Yeah, for sure. And I think like, just the sheer amount of power and electricity that they need to power these data centers, I guess at a certain point, the opportunity cost becomes very high, right? Because maybe we could have used that land better for something else. Maybe we could have used that power better for something else. And at this point, they're like going into it of like, if we invest this much money and this much resources into it, then we will reach AGI and make society better. But they also don't know if they're going to reach AGI. So, kind of a harsh trade-off in that sense.
Yeah, for sure. Okay, I see Michelle typing, but it seems like at this point there doesn't seem to be too many. Yeah, Michelle would love to invite for another workshop in the future.
Yeah, for sure. If you guys are hosting again.
See, I think the thing about having hackathons helps us realize the potential and the reach that we have, and having people like you come on and do workshops and give really awesome technical explanations and workshops is making us realize that we need to have a lot more often. So
Oh, thank you.
yeah, okay. It seems like, yeah, we don't really have any more questions now, but like Xinny said, the LinkedIn QR code is right there. And we'll be uploading this workshop to YouTube after we're done.
Yeah, happy to chat.